My name is Mohammed Imam. I lead the technical marketing team for Catalyst Switching, where we have recently introduced the Catalyst 9K switches. You probably have heard about it. So I'm going to go into the details of the Catalyst 9K. One of the unique things about the Catalyst 9K is that it is an open, programmable, and very flexible switch. You can do many things with a hardware box that typically used to be a very fixed piece of hardware and not much programmable. Traditionally, if you look at the last 10, 15, 20 years of the networking industry, switches have been built for certain purpose, and they can be used in just one way. But the Catalyst 9K has many features and many capabilities. And it's all driven by the architecture of the Catalyst 9K that I'm going to touch on a little bit, which makes this box a lot more flexible, programmable, and open for users to go and try using different programmable interfaces, tools, open tools, applications, and so on. We'll touch on that. Okay? So before we go deeper, in June of last year, we have introduced the Catalyst 9K family. This consists of the Catalyst 9300, 9400, and 9500. The Catalyst 9300 and 9400s are primarily the access boxes. The 9300s are fixed access boxes, stackables. And the 9400s are modular access boxes with different types of modules and supervisors. And then we have the Catalyst 9500, which is our lead distribution kind of low-end core switch, which gives you port speeds of 10 gig and 40 gig. Okay, so that's the portfolio that we introduced in June last year. The key thing about the Catalyst 9K is the foundational elements, both from the hardware perspective and from the software perspective. So from the hardware perspective, it is based on a very strong foundation, which is driven by the ASIC. Last year in Berlin, I have talked to you about the UADP 1.0 ASIC, and we have seen how programmability helps adapting to the newer technologies. This is UADP 1.0 that I talked about last year, and the Catalyst 9K is based on the UADP 2.0, which consists of 7.46 billion transistors and is across the family. So the entire family of Catalyst 9K is using the UADP 2.0. What does 7.46 billion transistor really mean? Every transistor that we add means more features, functionalities, more scale, and performance, right? I'll talk about that a little bit more in the next slide. The other key element from hardware perspective that we have is the x86-based CPU. And we'll talk about that a little bit more as well. On the software side, we have one common operating system, which is iOS XE16, right? If you look at the Catalyst switches in the past, we have had Catalyst 2K with different image, different iOS train, 3K, another train, 4K, another one, and 6K, another one. And that used to be one of the pain points for our customers to manage so many iOS trains different for different platforms and hardware, right? We have unified all of this into one. It's just one iOS train, and it's not just the train, it's just one binary file that you will run across all of these products, right? And that hopefully simplifies the image maintaining process for our customers. So let me talk about some of the newer introductions that we had in the Catalyst 9K. We have added the 48-port mGig model in the Catalyst 9K. This is shipping now. This has the first 36 ports as 2.5 gig, and the last 12 ports as full multi-gigabit, which can run on 2.5 gig, 5 gig, and 10 gig. And that gives you a a lot of port density for your 11AC wireless network. We have also introduced a SOUP1 XL, which is optimized for a smaller core. It has better bandwidth than the SOUP1 that we introduced earlier, and comes with multiple templates, which is suitable for core. So it has better table sizes for core deployments and aggregation deployments. You can deploy it with a collapsed access distribution kind of deployments as well. And then we are going to bring some more templates on the SOUP1 XL, which are going to be suitable for the new solution that we have, which is software-defined access. And you'll probably hear about software-defined access more during the day. Okay. And then the last one here is the multi-gigabit line card that we introduced on the Catalyst 9400. This has 24 ports of 1 gig, and the last 24 ports are full multi-gigabit. So that gives you up to 192 ports in a chassis of multi-gigabit, which is which basically future-proofs you for 11AC kind of networks. Okay. So these are the few introductions that we had since we launched the Catalyst 9K in June. Now let me go into some of the foundational elements of the Catalyst 9K. As I mentioned earlier, the first one is the ASIC. So from hardware perspective, the ASIC that we have is UADP 2.0, and this ASIC has the programmable pipeline capability, which means the forwarding plane can be programmed for newer protocols going forward, right?
Is that using P4?
It can use P4, but the programmability is coming from the programmable stages that we have in the ASIC, ingress forwarding controllers and egress forwarding controller. So you can actually program the ASIC for P4 today. Going forward, maybe there's a new protocol. We are hearing about Geneve, for example. Going forward, you can program that ASIC to work with any protocol.
No, I meant P4 as a programming language for the ASIC.
So it is based on certain protocols in the hardware as well, right? Driven by the OpenFlow. So you can use it if there is support from the software perspective, but the hardware is capable of handling that, right? It has enough programmable stages and programmable pipelines which can handle that. Okay, and we have actually have done these side projects of supporting P4, so that's definitely possible. We have shown it. So that's the key capability that we have. Another key capability that we have in this ASIC is adaptable tables. So typically in the ASICs, the TCAMs and the flash tables that we have are pretty much fixed. We used to have templates, for example, sometime back in the 3750s, but those used to be pretty rigid. You could not change much in those templates and profiles. The tables that we have in the UADP 2.0 ASIC are a lot more flexible, which means you can carve these tables in different ways for different deployments. So today, you might be taking this Catalyst 9K and putting it in a traditional deployment, which, for example, requires L2 access, a lot more host or routed entries or MAC entries. Tomorrow, you might be using the same box for a software-defined access solution, which might be requiring more host entries. Or you might want to use that same box in a distribution or core deployment where you are looking for more for more L3 entries and NAT entries, right? So you can carve those tables in different ways to adapt to the different deployment models that you might have, right? And we give our customers different templates, but in future we can actually make newer templates for different deployments. And the third thing that we have here is the scaling and performance. So with every new ASIC, most of the time we have better scale and performance. And on this ASIC, we have pretty much doubled, tripled, quadrupled the numbers that we had in the previous generation, which was the UADP 1.0. So you have a lot better bandwidth. You have 240 gig of bandwidth versus 56 gig of bandwidth that we used to have before. We have a lot better counters. We have up to 32 meg of buffer, the packet buffer. And we have up to 128,000 of net flow entries. And pretty much all the numbers are better in this ASIC.
I have just a quick question to the packet buffer, yeah? In your test, do you see that a larger buffer brings significant performance benefits in this case here?
So it really depends, right? It depends on multiple things. Depends on the traffic, depends on how we are allocating this buffer to the ports. So the 32 meg of buffer that we have is actually divided into two pieces because the ASIC has two cores. Each core has 16 meg of buffer, and that 16 meg is kind of spread around the number of ports. So it really depends.
So you have a shared buffer per
core. It's not per ASIC.
Okay.
Right? So the shared buffer is per core and not per ASIC. That buffer has some allocations to each of the ports, and then there's some free buffer which can be taken by the port which is getting maybe some bursty traffic, right? So if a port needs more buffer at a certain point in time, you can take the free buffer, but you can also go and take buffers from other ports. And
so this is dynamically allocated?
That is dynamically allocated. We have an algorithm which helps dynamically allocate those buffers to the port which is asking for more buffers. Okay. All right. Now, the second piece of hardware that we have is the x86-based CPU. Now, if you typically look at the networking equipments, we have not seen a lot of x86-based CPUs typically in our switches. We used to have PowerPC-based CPU. But in this day and age, when we have a lot of different network applications coming from the different developers, it's good to have an x86-based CPU because what you can do then, you can take an application off the shelf and start running it on the Catalyst 9K. You can actually go and run anything. Docker. You can run Docker. You can run containers. But you can also run Clash of Clans, right? Any games, Bitcoin mining. I mean, you name it, right? So you can run many applications because the applications are typically built for x86-based CPU. If you have a PowerPC-based CPU, you have to go and recompile that application and maybe do some changes. But you don't have to do that with the Catalyst 9K.
I think our delegate friend Nick would love to see that Perf Sonasi on your list. Yeah. Great.
Yeah, and I'm going to talk about Perf Sonar a little bit more.
Death of IPSLA.
Wireshark is nice.
Yeah, and so Wireshark we used to have in our boxes, but now you can actually host it in a container and get to the web UI as well, right? So it'll give you the full-blown capability of those applications. And we are showing that some of these applications in World of Solutions being hosted on the Catalyst 9K.
Something. So yeah. I think this is very important. Yeah. So the ability of running x86 apps on network devices. The only problem I see is that various applications usually have different storage and memory requirements. And typically a switch is not like a desktop computer that you can rip apart and install more RAM modules. So I think that unless you fix that problem and making the expansion and the upgrade of the hardware capabilities on the x86 part of the host easier, it's going to be slightly tricky.
So very good question, and I'll comment on that. So two things. When you're starting to run applications, you need RAM. You also need storage. And typically on the networking devices, we have very small amount of storage, like 16 gig max on flash. On the Catalyst 9K, from RAM perspective, we have enough RAM, and we allocate some RAM to the operating system. Rest of the RAM can be allocated to different applications. We don't have a huge amount of RAM, so you cannot run like 15 applications, but you can run a few applications. But so it depends on which applications you are running and how much that is using. But you have the ability to go and allocate how much RAM. In total, we have 16 gig of RAM, right? The other thing is storage. Where are you going to store those applications? Because some of the applications are pretty huge. So what we have done here is we have added external storage capabilities on the Catalyst 9K. On the Catalyst 9400, we have SATA SSD storage drive capability, which can take the storage all the way up to 1 terabyte. That goes on the supervisor, and you just get that much storage. On the 93, 9500, and 9400, you also get the capability of having USB 2.0, 3.0, which can take the storage up to 120 gig. So that part is solved.
Is it any SATA drive, or does it have to be Cisco branded?
Technically, any SATA drive, but I'm 100% not sure that if we are, it's probably going to work, but most likely it's going to be a Cisco drive that will ship with the Catalyst 9400. Okay.
Just one quick question. Can you share which x86 is inside?
We use it from different vendors. Intel is one of them, but yeah, it's x86. I mean, the important thing is here is x86.
Like probably what family you're talking?
Yeah.
i5, I said.
I can get back to you on that later. I don't have it from the top of my head. Okay, now the third thing here is the software piece. So we have talked about the hardware piece, but the hardware is not going to work without a good software. So if you look at the software on the Catalyst 9K, it is the iOS. But if you look at the history of iOS, it goes back all the way to 1980s when Cisco started. And when Cisco started, of course, iOS used to be pretty small, right? Very fast. It used to have some routing functionalities. But over time,
Then the voice people came in, yeah?
we have added hundreds of thousands of features, right?
People came in.
That sentence is quite interesting. In the beginning, it was quite fast, but then we added stuff.
So what we have done in the last 2-3 years, we have started to modularize the operating system. So we have broken the big IOSD blob that we used to have into multiple iOS subsystems and have started running it on a Linux kernel. And that has given us some advantage. But later on, we have also added IOSXE database. And that's one of the key things that we have in the IOSXE 16 with Catalyst 9Ks that gives us a lot of different capabilities that I'm going to talk about in the next few slides. This IOSXE database holds all the different states, the configurational states and the operational states of the system. It's kind of decoupling the code from the data and is storing all the data in the IOSXE database in a standardized format. And if one of the iOS subsystems has to fail or have to go for a reload, your data is intact. And that's why we are bringing features like patching, for example, right? So you can patch a software code and go and take just a patch. You don't have to upgrade the entire image, right?
Unless the data structures change on the DB, like unless you know the format of the.
Yes, of course, there will be exceptions. Yes, of course, absolutely. Then the third thing here is the Linux container support. So in the operating system, we have the Linux container support, which means with the x86-based CPU and these storage things that we have talked about, now you can run external applications. Okay? All right. So how that helps with some of the things here. Let's build this slide. So we have the entire stack which supports model-driven telemetry. From the operating system, we have seen that we have the capability, right? So the IOSXE database is powering a lot of these capabilities. What you can do really is you can take open applications, right? And use certain Yang models to subscribe for some data and get that data on a periodic basis or on an on-change basis, right? So you can get it on every half an hour or whenever a port state changes from up to down, down to up, you get some data.
So it's streaming telemetry.
It's a streaming telemetry, yes.
I just have to point out that because SNMP MIB is a data model, we had model-driven telemetry for ages.
Right. And we love SNMPs, right?
Well, no, we don't, but don't talk about model-driven, talk about streaming.
That's right. So we are streaming, but this is a different model. Instead of the SNMP pool model, this is the subscription model where you can subscribe to certain data and get that data. Once you get that data, now it's up to you what you want to do with it. There are open applications out there like Kafka Kibana where you can have a message bus, put those messages in a specific format and put it on a Kibana tool to visualize it, for example.
You can tell to the switch, publish any telemetry on a Kafka queue, and then subscribers get the...
Exactly. And we are showing that.
Really?
We are showing the demo for taking some of the data, for example, CPU data, putting it on a Kafka bus, and
So you have Kafka client on the box.
you have Kafka. You can have a Kafka client on the box, but we run it in a couple of ways. We run it. We have another tool running on the 9K, and then we have a system that is doing the Kafka thing. We have done it that way as well, and we have run it on the 9K as well. So you'll see, when you see the demo, you'll see a couple of different models, but yes, we can do that.
And the last thing, sorry, I promise. You said you use certain Yang models, right? And this is a problem.
Yeah, so I'll give you more insight on that. 80% or more than 80% of our features have configurational models. We have a modest number of features with operational models, but we are increasing quickly, right? So when we talk about this, we are talking about operational models, right?
It's Cisco proprietary operational model.
Okay, so Cisco has been contributing to the IATF open models, and I think Cisco is the biggest contributor to that. But the IATF process takes a lot of time, right? You have to go through that whole process to get it there. So what we do in the meantime, we have native models as well. So we are not stopping anyone to start using that, okay?
So just one, I have to ask, because there were the telemetry data, what are the capabilities when it comes to flow data that you can send out? Do you have sampled or full flow data that you can send out from?
You mean NetFlow data? We have full flexible NetFlow. On the ASIC itself is at hardware rate, at line rate, without impacting any performance. So you can get that data, and you can do many things with that data as well. So that's we are not necessarily streaming that data when we are talking about the streaming telemetry. That data can go to a NetFlow collector, and you can, but that's a full flexible NetFlow. Right. All right. We also have on-box and off-box Python capability. So you can actually run Python on-box in a container and run a script. In the earlier times, we used to have the expect and tickle. Now you can use the different models, run Python, advanced programming languages, and do many things.
Just to clarify, do you need a container to run Python in, or is it native in iOS XE?
Both. We can run it in a container, or you can run it natively in the box as well. And you can run it off the box as well. So that's pretty normal. So I think I've covered this slide because of the question earlier, but because we have this architecture in the operating system, and we have the x86-based CPU and the storage, we have the capability to host many applications. Now, when you are hosting the applications, I want to point out one thing here is you need lifecycle management of those applications. And for that, we have the DNA Center, which is going to take care of the lifecycle management of the. So you can, from the DNA center, and we are showing this demo in the World of Solution again, you can actually have an application like Perf Sonar. You can install it from the DNAC after allocating certain CPU and memory to each of the devices that you are seeing in the network. So when you go to the console, you will see the list of devices. You can select certain devices that I want to install Perf Sonar on these devices. You can say install, and off it goes.
Basically, a virtual infrastructure manager for switches, like vCenter for switches.
So it is becoming Cisco Prime 2.0.
Yeah, just I'm curious, did you ever run Perf Sonar? How much performance did you get out from one sensor?
So I haven't. I don't have a lot of insight on how good Perf Sonar is running, but we are showing that demo, and I think we can explore it there. But I mean, we have certain labs.
Basically, the question is how much bandwidth can you generate with the x86 CPU that you have on the box?
How much bandwidth for the application?
No, if you're running Perf Sonar, CPU is the limiting factor. So how much bandwidth, how much TCP can you push through with the CPU that you have there?
Dedicated, so we have quad-core CPU, right? So we dedicated a couple of cores for applications. So you can do that.
But I could have a Kubernetes cluster running on the switches, right?
In future, sure.
Why in the future? You said it runs Docker?
No, it doesn't run Docker today. It runs containers. It has containers capability, not Dockers.
Can we go back to the previous slide? There was a thing called JSON there. No, the one in between, the one that you skipped.
Yes. No, because I have covered most of this, yeah.
So you have netconf with XML and restconf with JSON.
You can do that, yeah.
It's shipping and it's officially supported now.
The netconf and restconf is supported in March. Netconf is supported today.
Oh, netconf is forever, yeah.
Yeah, well, yeah, probably. XML is supported. JSON, I'm not 100% sure. And restconf, probably it will come with that. But for these two, I'm not 100% sure, and this is not supported today.
Okay, so the gRPC is future.
Yes.
Okay, thank you.
All right, so let me just go ahead and summarize in the interest of time. So with the Catalyst 9K, with the foundational elements that we have with UADP 2.0 and the IOSXE database, and some of the other attributes that we have talked about, you are getting a completely new kind of network. It's kind of reinventing the network from a different angle. And you have multiple options. You can do things that we have talked about, which means you really require some of the capabilities from programmability perspective, some coding skills, and things like that. But you also have a turnkey solution in terms of SD access and DNAC, which is also using pieces of this and giving a solution to our customers, and you can just have it ready, right? So we have both options with the Catalyst 9K. You are getting a lot of different capabilities. It's quite open compared to what we used to have before, but you are also getting a tool and a new architecture which can manage your entire network the way you want.
I think that probably the next challenge would be, people have been waiting for the capability of running software on network devices for a long time. And it's like, we're getting there, but we are given we want to run on a highway and we're given like a small bike.
Yeah, it's a start, I agree. But again, I'll go back to the foundation that we have. I think we have a very strong foundation, and we are well set to take it to the highway, right? But we are taking baby steps now.